All right, this video is on 6.5, which is about translations of sine and cosine functions. So it's going to use some different shifts. If you would like to look at the graphing calculator exploration on page 378, that'll give you an idea of what this looks like exploring it. But we have two more pieces that you need to know when it comes to graphs of trig functions. So the first one is our phase shift or our horizontal shift. So shifting that left to right. That is located inside of parentheses, and you're going to see that with this K and the C. Okay. Our phase shift is equivalent to C divided by K. So you're going to need the number next to theta, and then if it's being added or subtracted on there. If your C is less than 0, you're going to shift left. If your C is greater than 0, it tells us that you're going to shift right. You'll see that when you throw that in. Okay. So first thing says state the phase shift for each function and then graph them. So here's my first function. Okay. So our phase shift is this C over K. I'm gonna have to adjust this. I can't write. So right here on this one, my C is the thing added onto it. So my C is right here. That's my C. And then my K will be that imaginary 1. So if I'm going to do C over K, I'm going to do negative pi over 1, or I'm going to have a phase shift of negative pi. Okay? So that means I'm going to move it over into the left direction. I'm realizing now I'm supposed to graph it and I didn't leave myself room. So we'll squeeze it in right here. Okay. Boop, I need a little more room. Okay, so there we go. Here's our graph here. I got negative 1, 1. My normal sine graph goes by pi over 2. So this would be a negative pi over 2, negative pi. So my sine graph, instead of being where it normally starts here at 0, this negative pi is telling me I'm going to shift my starting point to this location, and now I'm going to do my normal sine, which goes up, down, back around. All right, so there is my sine graph. My cosine graph here, I'm going to take a look at that the same way. So I'm going to do my C over K. My C is this thing added on, pi over 2, and then I need to divide that by my K, or I'm going to say divide it by 2 because I don't want to do another fraction below that. So this is going to equal pi over 2 times 1/2, flip that, and that means my phase shift is going to be over to pi over 4. So let's take a look at what that would look like on my graph here. So same thing, I'm going to make my graph. For this one, instead of going by pi over 2s, I'm going to go by pi over 4. This would be 2 pi over 4, but think about that. That's really equal to pi over 2. 3 pi over 4, and this one would then be pi. Okay. So I'm going to take my cosine graph, and instead of my cosine being at its top at, that is so silly. I don't know how I did that. -1, +1. Instead of it being up here at +1, it's going to start its curve right over here at pi over 4. And now I'm going to do my curve there. If you notice over here, that curve, you can't even see it, happens every pi over 2 units. These ones are every pi over 4, so I have to be thoughtful. I'm not going to then get to my next curve point till down here because my units are half as much as my units here. So that means my next unit down here at 1, oh, this is being so silly, will not happen until right here. and then I won't curve back up till over here. So I'm skipping one to get my units there. So my curve is gonna look something like this. Right? Okay. A vertical shift happens when we take our shift, and our vertical shift happens from the midline. So our midline, or our horizontal axis, is like where we would have our x-axis, but instead we are going to make that our midline. So that is our reference line or our equilibrium point about which our graph oscillates. So usually that's the x-axis that we go up, down, and around from that x-axis. Now that instead that midline is going to happen at a new point, and this is going to end up impacting our amplitudes. All right. So my midline here, the blue is my regular coordinate plane. My midline up here ended up in this location on this graph specifically of y equals 1. That's going to be an equation of that midline. Okay, so our whole graph is shifted up, and we pretend that that now is our x-axis. This is the information you're going to see. This is our full equation now of a sine and cosine. Okay, it tells you where y equals h is that midline. So if it's a plus or if it is a minus, that's going to be your midline, and then you would do your amplitude from that point. All right, so this problem says state the vertical shift of the equation and the equation of the midline for this function here, and then graph it. So let's start with our midline. This -5, that shows our midline. So the graph, the equation of the midline will be -5. So instead of our line going through our x-axis, it's going to shift down to -5. Then that will also impact the location of my amplitude. I'm just trying to grab a pencil here so I can show you my axis. The only other thing different here then is my amplitude. So I'm going to draw my axis for you. Okay. I know that I'm going to have to go down to -5, so I want to make sure there's plenty of room down below for it to go to -5. I'm going to leave this all the way up here. Okay. So this is the one time there is nothing here impacting our theta, so I can do my regular units. Okay. So this is the time our amplitude is going to be impacted. So now my new midline is going to go down here to 1, 2, 3, 4, 5, and this, I'm going to draw this line here, even though it's not really a part of our graph. That is now the new point that we are going to do our trig function around. So this is the line y equals -5. On here, there is also this 2 added. That 2, that's going to be my amplitude. So that means that from my midline, I need to go up 2. So I'm going to make this dotted line here. 2 up from my midline, and I'm going to make a dotted line 2 down from my midline. And that is going to be my oscillation point here, where I'm going to go up, down, and around. So I have a cosine. Cosine is going to start at the top. So I'm going to be top of my area. I'm pretending this is my axis here. And I'm going to go down like I normally would in the exact same units for my cosine. Okay, so I'm going to go up and down, 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 and there's my cosine. So now it is taken, it has been shifted down. If there is stuff attached to this with our K and our C, then that's going to potentially change how we're shifted over. It'll change the period of time in which it happens in, and we'll talk about that in the next video.